Welcome back, everyone, to the second day of AIIDE 2021. It's my pleasure today to introduce our second keynote speaker, Dr. Nettrice Gaskins. Dr. Gaskins earned her Bachelor of Fine Arts in Computer Graphics with honors from Pratt Institute in 1992, her Master's of Fine Arts in Art and Technology from the School of Art Institute of Chicago in 1994, and her doctorate in Digital Media from Georgia Tech in 2014. Her art uses machine learning and other algorithms to explore techno-vernacular creativity and Afrofuturism. Currently, Dr. Gaskins is a resident in the Autodesk Technology Center's Outsite Network and the Assistant Director of the Lesley STEAM Learning Lab at Lesley University. Thank you, Dr. Gaskins, for speaking to us today.
Good morning or good evening, depending on where you are in the world. My name is Dr. Nettrice Gaskins, and I'm here to talk to you today about algorithms of artistic style and pose estimation. I want to start with MC Escher, whose analog works were created manually using algorithms or step-by-step instructions. Here, the butterfly's wings are colored in such a way that mutually orthogonal circles are formed. To apply the circle limit algorithm, we must follow a two-step process. One is creating the basic motif, and then two is repeat copies of that motif around a hyperbolic plane. And I was really inspired by Escher's work when I wanted to teach AP computer science principles to high school students, especially students who were majoring in art of some sort, because it showed how creativity could be used in a way that was computational. And so I begin with Escher, and I begin with his use of algorithms as a way to talk about where we are today, which is when now we're working and collaborating with machines to create art. And the way we do this is through something called deep learning. And deep learning is a subset of machine learning that uses multiple layers in a network typology. And I'll talk more about machine learning as we go along. And so we have an input layer, a hidden layer, a couple of hidden layers, and then an output layer, and then the neurons that are moved across and through those layers to produce the output. So that's where we get the idea of a neural network. And so as it relates to neural networks, we have a researcher who was at Google named Alexander Morvintsev. And in 2015, he used an image of a cat and a dog as reference for deep learning and created what he called a nightmare beast. So here was the original image. And I got this from Artist in the Machine, a book by Arthur Miller. And you see here, he called this application, here's the nightmare beast. And then the application he used, he calls Deep Dream. And so this is where we were in 2015. So let's go back to that time. Morvintsev was part of a computer vision research team at Google who taught computers to understand digital pictures and sound. They were looking at convolutional neural networks. I call them CNNs, or they're also called convnets, that were able to recognize objects and spot patterns in data. And so there's another example from Morvintsev during this nightmare beast idea. You can see on the right of the screen, and also that these beasts, so to speak, or these new types of creatures were created by the computer trying to figure out how to use different animals. And so these combined animal images are what you give sort of like LSD-like psychedelic type of look. And this is 2015. So to train a CNN or ConvNet, you feed in millions of images from a database such as ImageNet, which is made up of over 14 million URLs of images annotated by hand to specify the content. And so lots of data can be used in a convolutional neural network. And ConvNets work in a similar way to the human brain. The first layer picks out an element of an image. The other layers pick out more and more details. And then the last layer assembles all of the elements into a final image. And here's an interesting kind of visualization of that on the right side of the screen, where you see the input and outputs and all the kind of processes that happen, picking out those features and things and flattening them and creating the final piece, which could combine, in this case, a horse, a zebra, and a dog to create another type of animal, perhaps. And so rather than reconstruct the original image, Deep Dream keeps the strengths of the connections between the neurons fixed and lets the images change. Thus, the machine can produce new images that are not programmed into it. And you can see another example with some ibexes, and then how going through the process of Deep Dream produces kind of a new type of image on the right side. And so in this image, we have Memo Etkin, who used Deep Dream to interrogate the government communications headquarters in Cheltenham, England. About the application of Deep Dream, Acton writes that when you show Deep Dream something new, it tries to make sense of what it's seen in terms of what it already knows, which in a real sense is how perception works, how we make sense of the world. And so this is his kind of demonstration of how Deep Dream works and kind of creates this kind of otherworldly or alternative reality by having the computer sense the world. And in this image, this is by Angelo Semeraro. He used deep learning to explore art on display at the Tate Museum in the UK. He discovered what he refers to as accidental renaissances, or modern images compared by accident that look like Renaissance art. After 2 days, Semeraro and his team found a match between 1,250 news images and 30,000 artworks. And it's from the Tate archive. And because it deals with numbers, not pixels, the machine was able to see what humans could not. And so you have this comparison or this match made by the system where it found some similarities between the contemporary image or the more contemporary image on the left, and then the Renaissance image on the right. We have Leon Gaddis, who he was grappling with the question of whether or not a machine could separate style from content while creating new art. He developed a neural algorithm of style, what is called deep style, which is an application that I make art with today. And so in this image, we have a town or a landscape, and then we have Van Gogh's Starry Night, and then Deep Dream. The process puts those two together, and kind of applies the style of Starry Night to the original image or source image, as we see here. And so this is the Gaddis style, or what's a deep style that was created by Gaddis and his team. And so in this case, I started with that in mind, with the Gaddis style and deep style in mind. I started using or exploring deep style using Deep Dream Generator. It's a platform that provides a set of tools that make it possible to explore different AI algorithms. The tools include the original application developed by Mort Vincev, which is the Deep Dream, which I mentioned and showed examples of, and then Deep Style, which is what I use, which is similar to what Gaddis was coming up with. And then there's something called Thin Style, which is using fewer hidden layers in the process. So it gives you a not so deep, thinner style of deep learning on with a source image and a style image. So this is available, it's free. It's something that you could go there and see what other people have created. So there's a community, it's a Patreon where you can actually become a member that has higher resolution images, or images that have more megapixels attached, so they're higher quality and higher resolution. So it's a site that's been around at least since I've known of it, since 2016, 2017, and it's still going strong. And I use this platform for my work, which I'll talk about. And so this is what I've been working on and doing using the deep style from the Deep Dream Generator. So there's the content, and I use stock photos and my own photos as the content or source images, and then the style. And I tend to use fabrics, things that are very abstract, things that are not necessarily, things are man-made in many cases, but definitely things that inspire me in some way or have some kind of personal connection. And so those styles get applied to the original image, and you see the output image on the far right in this case. And so this is it becomes lace. The original source image is almost as if it was created originally as a lace piece. Here's another example of Octavia Butler. and the original source image or content is on the far left. And then I actually began to do a thing where I would composite two outputs, two or more outputs. Sometimes it's more than two. And so you can see one output has a particular style and the other output has another style. And then I composite them and get the output that you see, the final composite image, which is on the far right. And so this is a process that I've worked on and kind of gotten better at over a period of a couple of years. So for this portrait, I'm actually in an exhibition at the Smithsonian that opens in November 19th. That's called Futures. And for that, it's a site-specific commission for the Smithsonian, where I created 11 featured futurists, and they requested that I do a self-portrait. So to do that, I applied my process using deep style. And on the far left is a picture of me. And then you can see the top style images that I pulled from. So when I kind of apply what I call an Afrofuturist lens, I look for the kinds of my personal experiences with Afrofuturism that kind of merges past, present, and future, sometimes space age, sometimes fantasy. And then I apply those styles to my source image, my original content. And in the end, I get the composite image that you see on the far right. And so it's a multi-stage, multi-step process, going through the deep style process over and over again until I get a composite image that I want to use. And so this is a mock-up of the exhibition, which will be in the Arts and Industries building at the Smithsonian in November. And some of my AI art that I'm commissioned to create have been added to this mock-up. So you can actually see, and there's an Octavia Butler, you can see Floyd McKissick, and I think Buckminster Fuller is in there, but it will be woven through, these images will be woven, printed out and displayed, and woven through like totems in the exhibition. And here are some examples. And so my approach to creating these portraits for the Smithsonian show, for example, Helen Keller, I used antique lace, Braille, script or written text. I used sepia, kind of watercolor as a base. I used other textures to create that portrait. For Alexander Graham Bell, I used wiring and sort of technology behind communications networks, and even the patent for the telephone. The actual drawing is one of the styles I used to create the composite image of Alexander Graham Bell. There's also Margaret Hamilton. So using ones and zeros of binary computer code, I was able to produce this particular portrait of her. And then for Graham and Corbett, the scientists who were responsible for the Moderna vaccine, I used images of the coronavirus, COVID virus itself, both illustrations and scientific drawings, and actual pictures of the virus became the style that I used to create that particular portrait. And then Leo Baker, I used skateboard and tattoo art and anime to create their portrait for the Smithsonian show. And then there are others, there were 11, so these are just some examples of what I created for the show using the deep style technique and deep dream generator. And so I began to really dig into deep style. And in this example of Aretha Franklin, I started using a Leap motion controller. You can see that picture of that being used on the left, which is a small kind of device that senses movements of the hands. And so I was producing, I wanted to create the fringe in Aretha's coat. And so I created code using processing programming language, and actually used the sort of arrays that came out of use of the Leap with processing as the style for deep style, for deep dream. And so you see, it was actually a series of layers, again, a composited image. But what was really cool is I was able to draw on top of the composited image using the Leap motion controller and processing. So it was both the style and the content images, Aretha's image that was black and white. And then using Deep Dream, I was able to use that array created with processing as the actual image style for the deep style image. And then on top of that, I was able to use the Leap again to create these kind of tendrils and things on top of that. So this was several layers. And again, as I'm going along with this, control does become something that comes out of the process. I'm learning how to work with AI, but also at a controlled level where I'm able to imagine in my head how I want something to look, and then imagine how the machine will produce it, and then somehow bridge those two things together, what's in my head with what the machine is thinking. And again, when they use the word collaboration, I believe that is collaboration where I'm able to do that. And so that's what you see here. And so more recently, in the last year or so, I worked with a team of women, and we used Trinidad Carnival as a vehicle in insightful exploration and education in artificial intelligence, art, and design. And so you can see this is the website, and Trinidad Carnival, or Carnival, and other places around the Caribbean and in the United States, was something that was really important to us to explore. We really wanted to interrogate AI and really see how far we could go with it in terms of how could we use it with data from the Caribbean, from Carnival, to create a new experience and enhance and elevate these cultural practices and rituals and performances. So let's see. Let me go back up a slide. So what Vernell Noel was one of the people on my team, and she was the kind of the PI, or principal investigator, of this project. And she's an architect who's was based in Florida, and now she's based in Atlanta and at Georgia Tech. And she started using the Generative Adversarial Network, or GAN. Here you can see it. And what a GAN is, you're given a training set, and specifically the style GAN technique, which learns to generate new data with the same statistics as the training set. So for example, a GAN trained on photographs can generate new photographs that look at least superficially authentic to human observers. So has many realistic characteristics, but it's otherworldly. It's produced by the process. So she was using dancing sculptures from Carnival, and what she would do is she would scrub the image set, the data set, to find the right images, and then she would the Nostalgia GAN technique would put those all together, and she'd create these kind of alien, otherworldly, or new types of dancing sculptures, which you would see in Carnival. So this is a virtual gallery where you could see all these kind of outputs from the style GAN. And she was using runway ML standing for machine learning. And so this is virtual. This is through Mozilla and the Mozilla hubs specifically, and you can go there now. There's a link, carnival-ai.com, and experience this gallery and see these kinds of style GAN generated images that Vernell was able to, or Dr. Noel was able to create. And that's what we did as one of the aspects of this project. Another aspect of the actually, before I leave that, this is kind of the process that you would go through using the style GAN, and how we went through it for Carnival AI. There's the first step, was data collection. So Vernell, Dr. Noel curated a data set of Carnival, so dancing sculpture images from Google. And then the pre-trained model. So Dr. Noel used Runway ML, which offers a way to do image synthesis using style GAN. And then she trained a data set. So Dr. Noel used style GAN to train the ML model, and then generated outputs from the Latin space. She generated new images using random points in this hidden space. They maps these points to output images. So this is the process to create the images you just saw from Dr. Noel for this Carnival AI project. The other technology or development that we were really into is using POSNet, or post estimation. And the way that it works is there are two steps. An output RGB image is fed through a convolutional neural network. You can see a representation of that on the right. So there's the image, there's POSNet, there's a heat map, and then plus offset vectors. And then you decode, the other step is you decode the algorithm A decoding algorithm is used to decode poses and then pose confidence scores, key point positions, and key point confidence scores from the convolutional neural network model outputs. It's very like lots of words in there. Basically, it's applying different key points to different positions of the body. So the image is the body. You see here the guy that's standing there. And then PoseNet applies key points to different parts of the body, like the shoulders, the elbows, the arms, the legs, and so on, the head, neck. And then it, as you're moving, and this is kind of something you can do with video as opposed to still images. And you kind of get a estimation of as output of this movement. So that's kind of how it works from a technical side. And then there are some ways to try it out online. This is PoseNet Sketchbook you can get from GitHub. And there's a basic demo, and there's a bunch of experiments using PoseNet to try to show how you would use that, such as using text. And so the movement of the body the text would move based on the movement of the body. There's the basic demo, and then the movement multiplier, where you multiply all those images to create kind of like almost a pattern. And so there are, a bunch of other examples to try out using the Google Creative GitHub for a PoseNet. So we decided to use PoseNet and pose estimation for Carnival AI. And so this is our Carnival AI app that includes 3 working examples of PoseNet in different ways. The first one is dancing with shapes. And you can see here, you can play with different sizes. And actually, I'll show a demo of this in a second. And color of the shapes, and as they move around, so the person's moving, and then the shapes follow the movement of the dancer. And so you can see an example, and then you can actually click there and use it yourself with your inboard camera on your laptop or webcam or whatever camera you have connected to your computer. And there's also movement painting. So using AI and the movement of your body to create art with different colors. And so instead, it removes the body, and it's really about creating a composition with colors and shapes. And it kind of has this kind of array. It's an array process similar to what I was doing with the Aretha Franklin image, but instead using AI. And in this case, using PoseNet and pose estimation. And the third one is kind of a smaller version, like you're dancing with yourself, almost dancing. So you're creating a dancing partner. And so it's almost like call and response. So you dance and the AI responds to you. And that's the third one that's working. And we also worked on one for digital costumes, where when you're dancing in camera, the AI applies different, maybe feathers or other types of clip artwork onto your key points of the body. And so in this next demonstration, I'm going to show you how that works with Valencia James, who was the 3rd member of our Carnival AI team. And she's a dancer based out of California. And so Vernell's from Trinidad, Valencia's from, I believe, Barbados. And then, of course, me, where I'm from the United States, but we were all kind of the diaspora working on this project. And so I'm going to show a demonstration of Valencia doing the Dancing with Shapes video. Let's do that now. Let's stop sharing for a second. And this is Valencia. I'm going to share one more time to make sure I get the sound. Okay. And so this is a few minutes, not very long.
Me and my crew gon' wild out, put on the best and style out. It's been a little while out. I am a circle of best friends, a circle of brethren, yeah. I have a big plan. My hand in your hand is all we need. Today I'm on a mission. I ain't stopping, I'm best friends and them, yeah. All hands put them up in the air. We gonna make some mess in here. We gonna make some mess in here. Gather your best friends and them, yeah. All hands put them up in the air. Everybody circle around. Today we shut it down, down, down. We gon' make a mess in here. Everything up in the air. Let me make a mess in here. Today we shut it down, down, down. We wild and we don't care. We gon' make a mess in here. Them circle and bad like we. Them can't go hard like we. Them cannot jump like we. They can't get on bad like we. Them don't know love like we. Them can't go above we. We unbeatable. We have the best circle around. We have the best circle in town. Oh, oh, oh. I have a circle of real love. And this what we made up, yeah. I have people around me, and they will defend me anywhere I go. Today I'm on a mission. I am stopping, I make my decision. Today I'm on a mission, and I'm moving full speed ahead. So right now I'll just gather my best friends and them, yeah. All hands put them up in the air. We gonna make some mess in here. We gonna make some mess in here. Gather your best friends and them, yeah. All hands put them up in the air. Everybody circle around. Today we shut it down. Today we shut it down. Them circle and bad like we. Them can't go hard like we. Them cannot jump like we. They can't get on bad like we. Them don't know love like we. Them can't go above we. We unbeatable. We have the best circle around. We have the best circle in town. The best circle around. We have the best circle in town.
So what you'll notice in this is kind of how slow it was. And what we learned from using PostNet is that this particular process, if you're using an older computer, there is definitely a lag. Computers with faster processors, more recent computers, the lag would not be as pronounced. But what we're doing here is we're testing out PostNet, testing out post estimation, and seeing post detection to see how we would create some visual representation of Carnival. In this case, we did 5 different dances from Carnival. And so she's doing one or two examples in this example that she recorded with her computer that had an older processor. We're recording that as data. And what we would do is we would have these Zoom parties. And so because Carnival in many places was canceled during the pandemic, we were able to bring in different dancers and people who would go to Carnival. And this is happening in the Caribbean community. People are doing kind of these Zoom parties instead of going to actual Carnival, which was outdoors and different places. And so we took that on and we did our own Zoom parties for this research project, for this Carnival AI project. And we had people from many different parts of the Caribbean would actually get on Zoom. And we would go through a presentation to explain how the AI was being used, and not in a harmful way, and not in a way that was extractive, but in a way that was about celebrating joy. And celebrating Black joy and Carnival. And so, and what would happen is all of the people who were participating in the Zoom parties would have access to the app, and that they would be able to try out the different examples of Carnival AI from the one that I showed, which is Dancing with Shapes, the one with the dancing partner, as well as the movement painting. And then they could actually send us what they had collected, or they could send us actual dances of them doing different versions of those dances. And we could use that as training data for the Carnival AI data set, whether it's GAN, style GAN, or for PostNet to create work. And so instead of pulling data from ImageNet, and using it from we're using very specific data from Carnival for this project using AI. The other thing you'll notice is what she would do is after a while, she would come to her computer, and on the right side of the screen, you see there's some settings and some different things she could choose. So she could choose the size of the circles or shapes, how many shapes were there. In this case, she's using a 5 for the size and then 40 shapes, which may or may not, with her processor, laptop processor, may not be able to show all of those. And then you could see that she's using circles only, but she could also use triangles. She was doing it on hips only, so that's only attaching the shapes to the hips. But if you wanted to, you would attach shapes to the shoulders, the wrists, the head, the knees, and the ankles. And these are all the kind of what PoseNet places these key points at. So you could choose all of them or one of them or a couple, and it would apply those shapes, or those shapes will follow those key points in the performance. And then of course, colors. So she chose random. And if you were, and this is something we did try with a faster processor, you could create many different shapes happening at generating through PoseNet, and then have like this kind of almost confetti or very carnival color-like array of circles or triangles happening as you're dancing. And so you see also the skeleton of the skeleton created by PoseNet of the body. So how it's attaching those shapes to the hips. And so we did this for the spring, and moving into the summer. We experimented in the spring. Moving into the summer, we actually had the Zoom parties in the summer, and then had a launch in September. And I'm actually going to point that out, and then I can end this and take questions. Let me stop sharing this. So I want to now go back to the app or the website we created for the launch and talk about that, and then we'll be done. And so this is the website. And so when you come to the website, which is carnival-ai.com, you can actually get to the virtual gallery, which is the Mozilla Hubs. And there's these virtual gallery rooms, and there are 5 of them. And this is set up by Vernell using the StyleGAN. She was able to create these dancing sculptures, and then she put them up in this gallery. Hopefully I'll be able to get in there. And so this is Mozilla Hubs, if you've ever used it, kind of a virtual gallery space for people. And we used it for exhibiting work from Carnival AI project. And very shortly we'll enter a virtual gallery space, and you'll see these kind of StyleGAN alien creations using the StyleGAN process. So I'm going to join a room. And
hello everyone, and welcome to the Museum of Black Arts, Design and Technology. Our current exhibit is entitled Black Arts and Culture, Dancing Sculptures, Artificial Intelligence, and Design in Carnival. It showcases AI-generated designs for dancing sculptures in the Trinidad Carnival. In this gallery, there are 3 moving images I want you to pay attention to. One at the front, a second on the back wall, and a third in the lounge, just off the main gallery space. We encourage you to take screenshots of these moving images as they evolve and share them on Instagram. Tag us at #CarnivalAI. In the lounge are photos of 3 master wirebenders, Narciso Gomez, Albert Bailey, and Stephen Derrick. Before you proceed with the exhibit, I would like to orient you and tell you more about the exhibition. I'll tell you about the Trinidad Carnival, about dancing sculptures, and about artificial intelligence. So what is the Trinidad Carnival? The Trinidad Carnival is about creativity, resistance, and joy. French planters introduced Carnival to Trinidad in the 1780s, but Africans, the Spanish, British, and the free people of color shaped it. When slavery was abolished in 1834, formerly enslaved Africans reinvented the carnival as a form of resistance, celebrating their freedom, expressing their creativity and aesthetic sensibilities. While Europeans participated in Carnival for fun and frolic, for Africans it was religion and a psychological release of tensions from segregation, oppression, and violent white systems of control. The term Trinidad Carnival does not define the geographic location of the carnival, but instead its origin and the main elements that define the carnival. The three main elements that define the Trinidad Carnival are mass, calypso, and steel pan. Mass being the masquerade, calypso...
I think I can leave the room now. So that is Mozilla Hubs, and that is the style GAN through Runway ML, and shows you an example of what a GAN is. And I'll go back to the slides now. And so it was really interesting to be able to use these technologies to do this project with Mozilla and to work with my teammates on my collaborators on this project. Show my screen again for one final time to wrap it up. Yes. So that is the carnival, both the, just to go back to the style GAN using Runway ML, and then you can see the example of the dancing costume through style GAN, and the output that was in the virtual gallery. She has a whole explanation and presentation about carnival and dancing sculptures and the tradition and where it came from, and then how we're using AI to kind of extend or to go further with using technology, what's happening in carnival. And then of course, PoseNet is the one you saw with the dancing shapes with the person, and the movement paintings, another example. And so these are all ways in which artists are using, or in some ways to which artists are using AI. And this is a way that we can explore style and aesthetics and how to use performance and culture as data to create artistic works. And so that's basically it for my presentation. And so if you have any questions, you can email me at Nettrice, Nettrice @gmail.com, or I can take questions some other way. You can find my work also online, and that is the end of my presentation. Thank you.